So hello guys, this is my first YouTube video. um, Actually I am preparing for my unit test of college, but I wished that like me many of you have problems like you don't understand the answers. So here I am, like even I don't understand. I am a 12th grade science student. Sometimes even I don't understand answers. So never mind, coming to our answer. So this is a 2 mark answer, like describe the magnetic separation process. There are some words in this which you might not understand, and this answer is being a 2 mark answer. Even 1 mark is important, even a half mark is important when it comes to board. So this answer came in March 17. So this might come, and there is a possibility that this might come. Even I don't know, but just thing tells me that this could come. So first of all, how to revise this? So this is simple, okay? First we have to write the question. So what is the question? Describe the magnetic separation process. First, the magnetic separation process. Here comes the question. Magnetic separation process, what is it based on? The magnetic separation process is based on the differences in magnetic properties of four components. So it is based on the magnetic properties of four components. What are the ores here? We have taken examples. So this is tannic oxide. This is coming to the answer, leave that. So you understood, this is based on the differences in magnetic properties of the ore. I'm sorry, the video like turns, I'm really sorry for that. It is based on the differences in magnetic properties of the ore components. So first, how did we write the first point? We first wrote the question, the magnetic separation process. The question, what is it based on? It is based on the differences in magnetic properties of the ore components. The second point, coming to the second point, what does it help in? So it helps in the magnetic. So what does the magnetic separation process helps in? The magnetic separation process, the magnetic separation method helps in either. Okay, I'm sorry, this is my first YouTube video, okay? Please ignore what all my mistakes. I would do better the next time. But however, coming to the question again, if either one of the gang, this is gang, this is not gangway, this is gang. If either one of the gang is attracted by a magnet, then the ore can be separated from the impurities with the help of magnetic separation method. So we can write it like this way: with the help of magnetic separation method, the ore can be separated from the impurities if either one of the gang is attracted by the magnet. So we can write, with the help of magnetic separation method, what does it help in? It helps in the separation of either the ore or the gang from the impurities. So the magnetic separation method helps in the separation of the impurities, separation of the ore from the impurities. So the third point, what does it require? It requires an electromagnetic separator which consists of brass or leather belt moving over two rollers, one of which is magnetic in nature, as shown in the figure. So we have shown the figure. Please don't do this way. That should be close. This should be close. This line should be close to this. You can use these type of scales to draw this diagram. I don't know like if the diagram is necessary. Yeah, the diagram is necessary. The diagram comes for 1 mark. So the pulverized. What is pulverized? Finely powdered ore. Pulverized ore is finely powdered ore. It goes from here, and then this is the non-magnetic. The leather belt. This is non-magnetic. What was that? Non-magnetic roller. This is non-magnetic roller. It goes from here, like this non-magnetic roller is required for this pulverized ore to go from here to this is the magnetic ore, magnetic roller. So the pulverized ore, the magnetic properties, the ore having the magnetic properties, it gets from here and it is dropped here. So we can draw this like this. It goes from here, it sticks here, and then it comes over here and it is dropped here, and the non-magnetic properties, like the non-magnetic ore, is dropped here in this beaker, and in this beaker it contains magnetic particles. And this whole diagram shows the magnetic separation using electromagnetic separator. This whole diagram, this is the electromagnetic separator. It requires an electromagnetic separator which consists of a brass or leather belt moving over two rollers, one of which is magnetic in nature as shown in the figure. This is the magnetic roller as shown in the figure. So revising, the magnetic separation process is based on what is it based on? First write the question. Magnetic separation process, what is it based on? It is based on the differences in magnetic properties of the ore components. The second point, what does it help in? The magnetic separation method helps in the separation of the ore or the gangue from the impurities. This is the second point. The third point, what does it require? It requires an electromagnetic separator which consists of a brass or leather belt moving over two rollers, one of which is magnetic in nature as shown in the figure. So coming to our fourth point, the powder ore is dropped over the moving belt at one end. So these are the consequences, fourth and fifth point. At the fifth point, at the other end, the magnetic portion of the ore is attracted by the magnetic roller and falls nearer to the roller, while the non-magnetic impurities fall separately farther off. So as you know, as I told you, the ore, it comes here, then it goes like this, and then this is the magnetic roller. अब देखो, coming to हिंदी, ये जो मैग्नेटिक रोलर है वो बस मैग्नेटिक प्रॉपर्टीज़ जिस ओर में रहेंगी उनको ही अट्रैक्ट करेगा एंड यहाँ लेके ड्रॉप करेगा, एंड जो नॉन मैग्नेटिक रहेगा तो वो तो इससे चिपकेंगे नहीं. मैग्नेटिक प्रॉपर्टीज सबको पता है, वो इससे चिपकेंगे नहीं, एंड जो वो फिर नॉन मैग्नेटिक यहाँ आके गिर जाएंगे. सो इट फॉल्स फार्दर अवे फ्रॉम द नॉन मैग्नेटिक बेल्ट, एंड the ore having the magnetic properties fall nearer to the magnetic belt. I'm sorry, गला दुखता है यार इतना बात करने से. At the other end, the magnetic portion of the ore is attracted by the magnetic roller and falls nearer to the roller, while the non-magnetic impurities fall separately farther off. The non-magnetic portion falls farther off and the magnetic gets attracted and falls nearer to the roller. So this is what I said. The non-magnetic falls farther off, the non-magnetic portion. The magnetic portion gets attracted by the magnetic roller and falls nearer to the roller. So here we took an example, cassiterite or tin stone. So simply cassiterite is a you can Google. Cassiterite is a reddish, brownish or yellowish mineral consisting of tin dioxide. It is the main ore of tin. So you can Google the pics. The first thing of memorizing something is you have to see a pic of it, like any pic. So you can memorize it faster and properly. So you can see a pic of cassiterite or tin stone. This is the same, cassiterite or tin stone. This is the same. Cassiterite is the main ore of tin. You don't have to write all the pencil things in your answer paper during boards. This is just for explanation. So cassiterite or tin stone gives SnO2, this is tannic oxide, plus FeWO4, this is ferrous tungstate, and MnWO4, this is manganese tungstate. So these both ferrous tungstate and manganese tungstate, they whole form wolframite. Wolframite is simply like मैंगनीज आयन टंगस्टेट, वो दोनों को मिक्स करके मैंगनीज आयन टंगस्टेट बनाता है. दिस इज कॉल्ड वुल्फ्रामाइट, ऑल्सो कॉल्ड आई कांट स्पेल दिस, hubnerite we can call. Hubner, right? I hope I spelled it right. If I am wrong, then please comment whatever I say wrong. I'm really sorry. So this is stannic oxide. Stannic oxide is simply colorless diamagnetic. Diamagnetic matlab non-magnetic. So this is non-magnetic, this is magnetic, and this is colorless. You can google stannic oxide, like you can google all manganese tungsten, ferrous tungsten, you can google this. And this gives wolframite, like it is crystal, like it's some kind of crystal, and that hole is known as wolframite. So this is our answer. I hope you got it. You can screenshot this, and you can learn it further. Thanks for watching the video. I hope you understood it. If you don't understand anything, then please comment. Thank you for watching. Subscribe and like the video.